All right, so here is the second section for chapter 2. This is the second page of notes here. Just to break it up a little bit. So we're going to deal with function notation. So you've seen some of this before. Maybe it'll be a little bit different for you, but this is kind of what you need to see. So some of you might have seen something like this before. This is f of x. This is another way of writing out y. So you might see an expression like this. You might have in previous years seen it as y equals 4x minus 5. Now what we're saying is instead of y, because y is a function of x, so the x changes what the y is. So we can also say instead of y, the function of x is 4x minus 5. That's all we're saying with functions. So don't freak out because you see f of x. That just means we have y is a function of x, meaning if we change x, it changes y. That's all that means for functions. So what we can do is we can evaluate some functions given numbers. So here we've got f of 2. So this means we're going to take f of x, which is given here, and every time we see an x, we're going to replace it with a 2. So here, f of x is 4x minus 5. So instead of 4x, we're going to have 4 times 2 minus 5. Please tell me you know how to evaluate that. 8 minus 5 gives you 3. You should know how to do that. If I'm not going to show the steps for that and waste the time, but you should know how to do that. We can do the same thing here. Instead of x, now we're going to replace it with negative 4. So 4 times negative 4 minus 5. Okay, this one I'll write out the steps. So 4 times negative 4, negative 16 minus 5. So negative 16 minus 5 gives you negative 21. Should be able to do that. Pretty straightforward. Let's try this with the h function now. So we've got a different function. The only difference between f and h, you're naming them different ones. So it's kind of like, you can think of this letter here where I say h of x or f of x. You can think of the f and the h as kind of like their names. So I'm naming different functions so you know who I'm referring to. So that's like each of you in my class, you have a name. I'm referring to you with your name. Some of you have the same name as someone else, so I try and refer to you as something else. But that'd be like if I have 3 Omars in my class. If I called all of you Omar, that would make things really confusing. Just like if I called both of these two functions here, if I called them both f of x, if I say solve for f of negative 4, it's hard to distinguish which one I'm talking about. That's the same thing if I yell out Omar in my class. I'm going to have multiple Omars looking at me. So try to distinguish between each one. That's all that letter means. So I can evaluate h of negative 1. So instead of x, put in negative 1. So I'm going to have 2 times negative 1 squared. So evaluate that. Negative 1 squared, just 1. So this just equals 2. Do the same thing for this. Instead of x, we're going to put a 0. So this is 2 times 0 squared, which gives us just 0. Okay, so that is the notation with this. That's a simple basic one. Let's try now, we're going to do something in addition to that function. So here we've got f of 2, but now we're going to subtract 3 from that. So what we're going to do, this is going to be equal to 2 times 2 minus 1. So that's the f of x. Then, in addition to that, I am now going to subtract 3. So I'm going to write this out explicitly so you can see this. This portion here, this is f of 2. And then I'm going to subtract 3 from that. So that's what is happening here. You don't need to draw all this. I'm just showing it to show you explicitly what's happening. So you can go through this, evaluate it. 2 times 2 gives me 4. And then I've got a minus 1 minus 3. So that's going to be minus 4 here equals 0. So you just evaluate that as normal. Let's try it here. So now I'm going to evaluate f of negative 4 and then times all that by 3. So let's use this notation again that I just did. So 2 times negative 4 minus 1. So this is my f of negative 4. And I'm going to times that by 3. So let's put this apart. So 3 times all of this stuff. So that's going to be 3 times, here we've got negative 8 minus 1 equals 3 times negative 9 equals negative 27. So that's the process. The algebra, or not the algebra, the solving this, just use BEDMAS. You should know how to do that, but that's the process. I'll do one with the h, and then you can try the last one here. So this is going to be negative 3. If you want, I am totally fine if you always do this kind of a notation where you put this giant set of square brackets to represent the function. If that helps you, use it. If you want to just do it without, because you can, I'm fine with that too. Whichever one you're most comfortable with, fine with that. So this is 4 times negative 1. So negative 3 times negative 4 just gives you positive 12. Okay, so that's that notation. If you're doing some sort of another operation outside of just simply the function. That's functions. Now we get into something that's a little bit more difficult. This is a composite function. So a composite function is a function within a function. This one's going to be a little bit more confusing, but I'm going to show you what this looks like. So what you're going to do with this is notice, let me recall back here, what we did is we took the 2 and replaced anything with x with that 2. So we're going to do the exact same thing, but instead of replacing with a number, we're going to replace with a function. So I'm going to take the outside one, f of x. So this is 4 times x minus 5. So notice I put up a set of brackets here. So because we no longer have x, I want to replace that with g of x. So wherever x was in this function, I'm now going to put the function g of x, which is 2x squared. This is confusing. Don't freak out. I've got a few more examples I'm going to go through. So I've got this. I am just going to expand this out to simplify it a little bit. So I'm just going to multiply the 4 in here. So we get 8x squared minus 5. So this would be what that composite function looks like. Let's try this again. So I've got the outer function g and the inner function f. So I take the outer function, 2 times x squared. Instead of x, I put this bracket. And inside the bracket, I'm going to replace it with this f of x. So 4x minus 5 as such. And then I evaluate this. So remember, this is the same as 2 times 4x minus 5 times 4x minus 5. You should, hopefully, know how to multiply this out. I hope so. So you just go through and expand this. I'm not going to show that because that defeats the purpose of what I'm trying to teach in this. What you're going to do, you'd expand this and multiply it to get the answer. So you would have to evaluate this to get a final thing that looks something like this. But for the sake of time, I'm not going to do that. That's something you should be able to do by yourself. So let's do one more thing. Let's do f of x. So f of x, 4 times x minus 5. So that's the outer function. Then we replace the x with f of x. So inside I've got 4x minus 5. This one I'm going to simplify. It's not too bad. 4 times 4 is 16x minus 20 minus 5. So we get 16x minus 25. This one's a triple. I'm not going to do it, okay? If you want to, you can. This is like an extended, if you want to challenge yourself, give it a go. But I'm not going to do that for the sake of this video. That's not going to come in the test. So it's more if you want to see if you're fully understanding it, you can give that a go. So now let's try this with actually a number inside. I'm going to show you two methods. One that I think is a little bit easier and one that's more doing algebra to solve it. So first one I'm going to do is I'm just going to work my way inside. So I'm going to do it like I did above and then put a number inside. So I'm going to go through and say, okay, the outer function is f. So 4 bracket where the x was minus 5. Then I'm going to do g of x, so 2 times x squared, but instead of x, I've got 1. So I've done this, it's kind of like a triple section here. So I'm going to evaluate this. So 1 squared is just 1. 1 times 2 gives me 2. So 4 times 2 minus 5. So 8 minus 5, this gives me 3. That's one way you can do it, is by solving like this. But what I'm going to assume, and this, I hope this isn't a wrong assumption, the easier thing for you guys to do is going to be to evaluate the inner one first and then apply it to the outer one. So I'm going to first figure out what is f of 1. Again, this is the second method. So f of 1 is 4 times 1 minus 5. So just 4 minus 5, which gives me minus 1. So this is g of negative 1, because f of 1 is equal to negative 1. Now this is easy to evaluate. I'm just going to do g of negative 1. So this is going to be 2 times negative 1 squared. And negative 1 squared is positive 1 times 2 is 2. So this is my final answer. I'm going to guess, correct me if I'm wrong in class, this way seems a lot easier. So that's what I'm going to do the next one as. This one, in my opinion, is a little bit easier. If you like this one, because you want to get used to doing the composite functions like this, by all means do it. This one actually stretches your brain a little bit more. So if you want a little bit of a challenge, do it that way. If you want just the simple way, do it this way. Let's try it again here. So I've got f of 2. So first I'm going to evaluate the little part, the inner part here, f of 2. So 4 times 2 minus 5. So 8 minus 5, here's 3. We get this. So then we now need to evaluate what is f of 3. So f of 3, 4 times 3 minus 5. So 12 minus 5 gives you 7. There's your final answer. Again, if you want to do the triplet, try it just as an extension, but you don't have to. So what if I give you the reverse? So what if instead of giving you f of g of x or g of f of x, what if I gave you the full function and we now need to evaluate the inner one? So I'm not telling you, you've got f of x, which is a composite function, a g of h of x. So I need to find what is the inner function. So for instance, we're looking back here. If I wrote it like this, here's the inner function 2x squared, that's the g of x. The outer one is 4 times x minus 5. Or here, this bracket, this is the inner function. The outer function is 2 times x squared. So I'm going to do that here and evaluate this. The nice thing is, if you have a set of brackets like this, that is always the inner function. So this and this, notice that repeats. So this is going to be the inner function. So h of x, the inner function is x plus 3. I'm going to replace each of these with x, and that's going to be my outer function. Sorry if you can hear the honking. You're just getting authentic noises in the background here. So I replaced x plus 3. I've got x squared plus x minus 1. So those are my two functions. Pick the inner ones, replace that with x, and that gives me the outer one. So we can try that again here. This one doesn't have brackets, but I'm just going to take what's inside the square root here and turn that into a bracket. So my inner function, h of x, is going to be x squared plus 1. That's the inner function. The outer function, replace that bracket with x. I get the square root of x. You could, in theory, do this differently, but there could be multiple answers. This one makes the most sense. You could say x squared is your inner function and then work with that. It doesn't clear it up as nice as this, so I'm going to stick with that one. But again, if you wanted to take this and you wanted to go, let's say, here's my function. If you wanted to say, here's my inner function, so h of x is equal to x squared, and then the rest of this here, so we got x plus 1 square root of that. If you wanted to do it like this, you could. This function isn't as nice. That's why I'm not suggesting it. But if you did either of those, they would both be correct. So that would be totally fine. All right, so that is the conclusion of Chapter 2 with the functions and evaluating those functions. So again, make sure you're jotting down questions, starring the ones on here that don't make sense. So when you come to class, you're ready to go with these questions. And if that's all making sense, then you can start working on the practice problems.